it was a chapter in my life that ended, and I turned all the pages of all the books and stored them. However, recently, but I've been in aviation since I was 15 years old. Actually, the first time I flew a glider was when I was 15. And even before that, I had experience, but only to some people who would be listening, would be willing to listen to later on, I'll tell you about. But, what I'm trying to say that I follow the pattern of aviation from 2 points of view. As I'm an engineer as well, and also a pilot and a flight engineer, I followed it and I saw what's going on with the development of the airplanes, which are becoming more and more sophisticated, and on the other hand, the quality of the pilots, which is also going down. And I'll start. I have to pick up my breath because I was walking all the way from downstairs with a suitcase. Okay, so I'll start with a personal story. In 1964, I read an article in New York Times, and the article was a synopsis of a lecture that Isaac Asimov gave in public. He predicted that in 50 years, meaning 2014, there will be a different world, and he predicted all kinds of robots and flying to space and all kinds of things that many of the things he predicted really came to light. For example, some of the things are completely irrelevant. For example, that before you go to bed, you talk to your robot and say, I want for breakfast, and you give you all the menu. And when you come in the morning, get in the morning, all the menu is on the table and you're ready to eat. The point is, rich people, they have somebody to prepare the breakfast for them. Poor people don't eat breakfast, and middle-class people don't have time to eat breakfast. So all this idea did not really exist but this is back in 1969, after they put the man on the moon. Isaac Asimov was in New York signing a book, and there was a big line, and nobody could get to him or talk to him. But finally, the man had to go to the bathroom. And at the same time, he was standing next to me in the bathroom. And I said to him directly, do you really believe that all you predicted in 1964 will happen at 2014? He said, did you read my article? Did you listen to my lecture? I said, no, I read it. So who are you? So I told him who I am. I'm from Israel, and I'm fly. He started to talk to me in Yiddish. And I said, sorry, I don't speak Yiddish. So he said, and then we finished, and I washed my hands. He washed his hands, and I said, okay, may I introduce myself officially? And then he said, you are something else, let me buy you a drink. And we went to the corner of the bar, and he said, what do you think? That aren't you afraid that a robot will sit in the cockpit and take your controls and fly the airplanes? I said, do you mean a machine with a head, hands, feet? He said, yes, yes. I said, why? You can put just a box. Nobody needs the head and the hands. You just can put a box to do the job. You don't need all these gadgets. I said, and why do you make all your robots human, like you look like human? And he said, this is good for the story. Anyway, he also confessed to me that he never flew on an airplane and he's afraid of flying. So this is the end of the story. Now, but what I'm trying to tell you about is the prediction of robots of flying the airplane since that time. And there were all kinds of developments, and practically it is possible to do it today. But now, let's start back in aviation, and how many people flew the airplane? Well, let's say the bomber, the Lancaster, the British bomber, had a pilot, only one pilot, a flight engineer, a navigator, and a radio operator. This was the basic flying, to fly the airplane. There were also bomb aimer and gunners and other things, but basically this was the... Now, that was a big mistake, flying with only one pilot. It was a big mistake because the engineer had a lot of workload. The navigator actually was the chief of the flight because he actually was the commander of the flight, the navigator, not the pilot. And the pilot got order what direction to fly and what heading to take in order to avoid army gunfire and get to the target. But they lost, the Lancaster did not fly as an airplane more than 30 or 40 missions. He was shot down before that. And most of the reasons were incapacitated pilot, injured pilot, and no other one to fly the airplane. So a lot of damage was done because of one pilot. So they moved to two people in the cockpit, 2 people in the controls, and there was a hierarchy now. There was a commander, and there was a first officer, and there was an engineer. The engineer had his functions. He had a huge panel. He was in charge of the engines and hydraulics and everything. And there was a navigator. And this was better from crew complement. It was safer. Now there was a kind of dynamics in the cockpit. The dynamics was, although there was a commander, there was also a kind of coalition. Because when 3 people are coming and one is completely different profession, automatically you're creating coalition if you have any problem or if you have any suggestion. And there are 2 against 1, or let's say a debate, and not really an order, which could be done in only a 2-man cockpit. And then it went on, and the radio operator was removed from the flight, and then it was 1967, there was no more radio operator, and in 1970, there was no more navigator. That's the way it went. Now, when they took out the navigator from the jetliners, there were 3 people in the cockpit. It was the first officer, the captain, the first officer, and the flight engineer. Now, I flew in this hierarchy from the 60s. I flew with the navigator, but from the 60s, from the 70s, there were 3 people in the cockpit. Now, those 3 people were actually, each one of them has a part in the flight. It's not what just was one person flying, the other one are getting orders. All the 3 has a function in the flight, and I'll explain it. You see, men or people make mistake. And the idea is to find the mistake before it becoming critical and to fix it. So all the hierarchy in the cockpit was done that each one of the 3 people was watching the 2 others at all times. Now, if not really watching the 2 others, he was watching his instruments. So the idea was also the usage of the facilities in the cockpit were the same. For example, the pilot was using inertial navigation and autopilot. And the autopilot, inertial navigation was controlling the autopilot, and the captain could see on his instruments exactly what those 2 are doing. The first officer did not know what the inertial navigation is doing. He had different radio navigation and other instruments to watch the captain. So if there was any discrepancy between the navigation, it would be right away on the spot. Now, the engineer who was in between them, slightly on the back, he could watch both of them. He could see, and he also could see the interaction between the 3 navigation units, because these 3 navigation units could make a majority decision. 2 against 1. If the 2 thinks you're in a certain point and the other one thinks you're off, they would say you will send him home. If not, they'll make a kind of interpolation between the 3 of them and will give the command to the navigator will fly the airplane. Now, all this interaction between the three people enabled the cockpit to find mistakes before they happen and to fix them. Now, because the idea is not to condemn anybody who made mistakes, the idea was to help fix it and continue. Okay. And now, a small story. There was one of our captains was making mistakes, but every time he made a mistake with a different crew. Once he he selected an altitude that didn't stop at that altitude. The other case, he forgot what was the altitude. It was in Nairobi, and all of a sudden we're in the outer market, very close to land, at a very high speed, gear up, flaps up, everything was, it was a big mistake. Now, we fixed it, other crew, and nobody really paid attention. However, because of the hierarchy, because of the paperwork that we do, we wrote those mistakes in order to get it to the training department and to fix if there is any training problem, if there's anything that a mistake is repeatedly coming more and more times. So the idea was to learn and to fix it. Now what happened is they found all of a sudden that this captain is making more mistakes than usual. So they sent him to the simulator for test, and he failed. So we said, okay, another test. He was 57 years old, and another test, and he failed the other one. We said, okay, we'll give you an instructor, fly a month with a captain, instructing captain, and we'll see what happens. A month later, he was rechecked again and failed. So let's say to him, okay, what do you want to do? So he said, I want to retire. And he retired at the age of 57 with benefits and on. Now, about a year later, he was diagnosed with Alzheimer's. The simulator knew it before. So, and the crew. Now, the crew couldn't know because every time it was a different crew. But the simulator really knew that something is wrong with this guy. So the training in the simulator is a very important part of the training, and also, I would say, it's a diagnostic instrument. Now, why I'm saying this? Because many airlines don't send the pilots for the simulator training. They do the minimum necessary according to the regulators' demand, but not more than that. And many accidents are because of that. Okay, so we are talking about 3 people in the cockpit and correcting the mistakes. And by the way, all the systems also work in this way. It was a new concept started on the 70s. Not a single component on the airplane, unless it's an engine, can cause the airplane to be in dangerous conditions. Not hydraulic pump, not single hydraulic pump, not single fuel pump, not fuel leak of a certain magnitude. It is all safe. Also, it brought another element to the maintenance point of view. You don't remove parts for checking them. You fly them on condition. You remove them on condition, like you do in the car. Something fails, you replace it when it needs to be replaced. But it was safe, and it was done perfectly. And from that point of view, I think the airplanes are perfect today, except that, we'll get to it, the system is not backing up the perfect airplanes. Okay, now let's go back to the pilots. So we have, in the 70s, there was a big crisis, a fuel crisis, and Boeing came with an idea. Why don't you fly with only 2 people in the cockpit? Not 3. Remove the engineer. We'll give you instruments, we'll give you computers, and you'll fly it with computers without need of an engineer. The idea was okay, and all the airlines accepted it, said, okay, we're going to save money. Wrong. You see, those big jetliners are flying over 10 hours, okay? Flying 12 hours, up to 17 hours, they can be airborne. Now, if you take only 2 people as pilots, they can fly only 8 hours. After 8 hours, you have to replace them with another one. But you're flying, so you take a double crew. Double crew is 4 people. If you compare it to the 3 people who could fly 13 hours, that's a loss. They lose money on extra expensive pilot. That was not necessary to take it before. But now, the point is not saving money or not in this case. The point is how safe is, what is the interaction between 2 people in the cockpit? Now, there is one in command, right? He's the captain. And the other one is the first officer who wants to be a captain, who flies sometimes with a captain, which is going to be his instructor. He flies with a guy which will, if he writes reports about him, he will never become a captain. So he's not assertive enough to give any remarks or any comments to criticize the captain. And you have 25, I think it was 25 years ago, was a Japanese airline in San Francisco. Interaction between the 2 people didn't work and undershot and crashed. Korean, not too long ago, in San Francisco, again, the same problem. There was a pilot flying, not experienced enough. The other one didn't tell you, kind of miscommunication, crash. Not only one person was killed over there, I think. It was, from a truck, from a fire engine truck. And now, if you wish to go, you said, okay, this is the mentality of the Orient. But go to Swissair. Swissair, flight 111. You can check it. Believe me, it's a horrible story. 2 people in the cockpit. One is saying a word, the other said amen. He said exactly what he said. And what was the problem? They had smoke in the cockpit. Smoke in the cockpit. Now, when you have a smoke, first thing to do is to identify the source. Where is it coming from? Is it air conditioning? Is it fire? Electrical? You have to find out what is going on before you do anything. So the captain decided it's air conditioning, and the first officer said yes. And it's all recorded, by the way. It's all this thing, but I'm telling you is recorded, and it's a 40 minutes saga. So you can really see it and read it. And so now the first officer is saying, okay, now is it, now the procedure calls, ask the cabin if there is smoke in the cabin. Because if there is smoke in the cabin, it's definitely not electrical. It's air conditioning, because it's one cabin in one air conditioning system. So what we were doing is, he asked the cabin attendant, is there smoke in the cabin? And she said, yes. And the next thing they said, okay, it's air conditioning. And they start doing procedure to remove the smoke. And one of the things to remove the smoke was to stop a recirculating fan that circulates the air in the cockpit. And this is immediately increased the fire. Because
why?
I'm not getting into it. Because of the location, it was sucking the smoke to a different direction. All of a sudden, because there was it was not recirculating, it all concentrated in the cockpit. So there was a very heavy smoke now in the cockpit. And now they called Halifax and said, Halifax, we have smoke and fire. We would like to land. Where would you like to go? They said, Boston. I said, what? Boston is 300 miles, and we are 50 miles away. Why don't you land in Halifax? Quiet. They didn't say a word in the cockpit. It was quiet. Why? We don't know. But in my opinion, they did not have the charts, the landing charts for Halifax. So, huh?
They did not have what?
The landing charts, the map for Halifax, the map of the airport. Or they couldn't find it right away. Now, what is the guy saying to the controller of Halifax? I think I need to dump fuel. And he went in, and I'll dump it over the sea. So now he turned into the sea to dump fuel. Now, this was stupidity from here to eternity. The engine, you are in fire, you are in smoke, you are on oxygen. Just land as soon as possible. And they decided to dump fuel. Actually, they didn't went to dump fuel, they went to find the chart because they could not admit that they don't have the chart or they don't know how to. Instead of saying, okay, we can't find the chart, it fell down, coffee was poor. Whatever happened, give us instructions. Give us the radar direction so we can get to the airport. This is so simple. They did not declare emergency. They went to dump fuel. Okay, they didn't return from there. All the 92 people, I think, were on board were killed. And this is because of two things. Identification of the source of the problem and the hierarchy in the cockpit. One did not, one agreed to what the other guy is saying, and that's it. And there was no argument, no discussion.
So there was one person only?
No.
So there was one actually
one
person.
Mind.
One
actually,
mind.
Yeah. One mind.
It was one mind, one boss. Okay, one boss.
The other was insignificant.
Follower.
Yeah. And the more you check it, the more you see things like that. Now, we are coming now back to the system. Up to now, we were talking about the pilot. Let's talk a little bit about the system. The system wants to save money. The airlines want to save money. And the two elements that you never will be able to see from the outside are the safety and the security. And they try to save on them because you don't see it. Passengers don't know if the air maintenance was okay. Passengers don't know if the pilot got the right instructions. Passengers know nothing. They have to see from the aspect of the seat and the tray, and this is what they know about the flight. And if they charge them a few dollars less, they go to that airline without even knowing that on that airline they saved on the crew. Now, this is interesting, and why I started to talk about it. Actually, I started to talk about it after the incident of the Malaysian aircraft. Malaysian aircraft, well, there's speculation all over the
one that disappeared, yeah?
Yes, the one that disappeared. There's speculation all over the media for weeks. And when I started to read what they brought over there, I got the idea that they are barking on the wrong tree, that it's not the case. Why they are looking for for example, they're looking for the red or black box. Why? The airplane is capable of transmitting all the information outside. There is no need for the box. Listen to me, no need for the box.
Are they taping it, storing it outside as well?
No, because the airline is not paying the money to store the information. So they are looking for the box because this it's written that you must have this box on board. There are 80 channels of data can be transmitted from the airplane. They use only 2 of them when they open the doors and some other thing. But Air France is using maintenance as well, transmitting maintenance. But nobody is using all this data. And more than that, the engines on that Malaysian aircraft.
All this data? Airlines?
I'll get to it. We have a completely different system from the training, from the checking, from the simulator. It's totally different, and no pilot is accepted to the company under 2,000 hours. That was the reason why after my training, I was not trained in the army. I was not, they didn't want me to fly as a pilot. And they told me, okay, if you fly as an engineer, we'll calculate some of the hours as a pilot, and then you'll be able to fly. In 10 years, you'll be able to fly so the point was, it's different. We do it in different way. But now let's back to this airplane, the Malaysian. All the things that came out indicated, like they wrote there was no transponder, there was no radio, and immediately I said, okay, they are not transmitting it, and no airline is transmitting all the information. But what about this transponder and radio, the VHF radio? Transponder, just to tell you what it is, it's a response from a radar, ground radar to the airplane transmitting back. So the ground controller can know I have 6 airplanes that I'm controlling, so all of them has a number and a name, and I see that all of them, and the rest of them are just blips, which I don't care. So he's having kind of, the airplane is sending a kind of, we call it as a card, a personal card. And this is my card. And this transponder was shut down or stopped working. And now I started to think about it, and I said, okay, I've been into this movie before. It happened to me that the transponder and the VHF radio stopped working on a flight. And not only that, I also got in a very dangerous situation because of a volcanic ash cloud. This was a flight to Anchorage. And you would expect that the Ring of Fire, all these volcanoes around the Pacific, everybody would know that there is an eruption and there is a danger of, but no. The volcanic ash is invisible to the radar. You don't see it on the radar. You don't know that there is a volcanic ash. The pilots see it as a dark cloud. It's a cloud, slightly darker than normal cloud, but it has a significance. One significant thing is that when you see it, and there is a light, you see a kind of a hat over the cloud. It's like a cumulonimbus. It's like a storm cloud, but it has a hat on top. Now, this is a kind of separation of the volcanic ash by static electricity, the positive and negative charge, and that's how it comes to shape. So we know that there is static electricity, there is poisonous gases, and there is also magnetism. And the volcanic ash is mostly silica, which is abrasive and can damage the engines, can damage the paint on the aircraft, and damage the skin. Now, I was in such a condition. Nobody knew in Anchorage. An hour and a half before landing in Anchorage, we came over the North Pole. It was a direct flight from Amsterdam, right over the North Pole. Very, very difficult flight because we don't have compasses over there, and we had to rely on the national navigation, and you don't know, every direction is south. So it's kind of weird, believe me. It's kind of weird, and if you're not do it, so we were under a lot of, I would say, concern all the time, all this flight, and all of a sudden, I started with the smoke of the sulfur, and then smoke in the eyes, a little bit of irritation in the eyes, and then a minute and a half, what I'm describing now is a minute and a half, I started to see that the temperature, the generators, okay, the generator came on and off, and the temperature of the engine was going up. Now, so immediately, it's kind of an instinct. Temperature going up, you pull down the throttle to reduce the temperature. It is kind of second nature to every pilot. So we reduced it to within the limits, and it was still going up, so within the limits, until we got to an idle with all the engines, and we started descent because that without any power of the engines, either you lose speed or you go down. So we started to go down, and now they started to flame out one after the other. And finally, about 2 minutes or 2.5 minutes after the start of this millions of tiny pieces of light that coming hitting the airplane because we put on the lights to see them, we were completely without any engines and no generators. Because on the 707, 200, when you have no engines, you have no electricity. Now, there is on an airplane the design of the hierarchy of electricity, and the final one is even a battery. And the battery is for only 2 things: to run the radio and to reignite the engines. This is it. Nothing more than that. Now, we are now with no electricity descending, and the engines they stopped rotation. Believe me, it were very, I would say, stressful, scary. I don't know. I was so busy. I don't know if I was scared, but I didn't know what to do. And after when we got to 14,000 feet, I started to see motion on the engines. Okay, we didn't know what is a volcanic ash at that time. We didn't know nothing about it. Now, what happened is that actually started to run, to turn around, and we started the engines and we landed. The engines were damaged, but the point is, I'm saying all this on because the transponder didn't work and the radios didn't work because of the cooling system. The cooling system of the airplane is the same air that's coming out from the outside is going through the electrical instruments and discharging overboard. And this is how they're cooled. Now, if this air is charged with static electricity and magnetism is going to cool the electronic plates, all of a sudden you're getting shorts and nothing works. And that's what happened. And so we, after landed, they replaced 4 engines, they replaced many of the systems, and we signed a waiver that we'll never talk about it. And the reason was, because now I can say it, but the reason was that we were carrying a 40-meter long part of a drilling tower, oil drilling tower, which belongs to a Saudi sheikh. And this is the time of war. Okay. And they didn't have a place in Amsterdam to keep this big monster. So they found a place to put it on, and Shell company decided to move it to Anchorage. So they hired the only airlines who flew at that time, which was the only cargo. So we took it over there. Now they gave us the engines. We signed to get new engines, and the airplane in 48 hours the airplanes were ready to go. And I am not supposed to tell you the story, but I'm going back to the Malaysian aircraft. We were lucky. After this incident, I went to a convention in 1991. Actually, it was years after this. In 88, there were about, no, sorry, I'm mixing the dates. So there were many, we were lucky, and we were lucky because what we did was exactly what we were supposed to do if we knew in advance that we were hitting volcanic ash. We reduced the power because the silica, which is melting at 700 centigrade, becoming like a gooey thing that sticks to the engine. But when it cools back, it's becoming a dust again and it goes out. And nothing happens except the erosion that it causes to the blades. But without it, it's going it's very safe. So we didn't know it, but we did it. Also, the going down and waiting for the engine rotation. We didn't have any choice, but this is what happened. And it was, so and we did not move. The only thing which later came on into the procedure, what to do, is to turn 180 degrees from the cloud back. Now, no pilot will turn 180 degrees. Because when you turn 180 degrees, you're backtracking, you're on track, and there might be other airplanes over there, above you, below you, we never do it. What we do, we take 140 degrees as getting out of the airway, and this is what we. And now coming back to the Malaysian, that's what we did. We were lucky; we did not have the poisonous gas, which is very many times apparent in the volcanic ash. Now, the gases in the volcanic ash could be basically 3 kinds of gases. The CO2, which is not poisonous, and it's heavier than the air. But if it takes the position of the air, then you have no oxygen. If you are in an area full of CO2, you cannot really breathe, or you breathe, but you don't get the oxygen. But it's not poisonous, and it's heavier than the air. The other one, which is not heavier than the air and stays for a long time, is the monoxide, carbon monoxide. This is very dangerous. This is poisonous. This is killing you, in a way, in a very small percentage in the air. And the third one is the sulfur and which is also a dangerous one, but it's also heavier than the air. So basically, it's quite possible to have this poisonous gas. And this poisonous gas is a silent killer. You don't even know that you are going to die when you breathe it. And it doesn't have any smell or anything. So I believe that the Malaysian aircraft got into volcanic ash cloud, which there are evidence that about 2 weeks Before that, there wasn't a big eruption in the area. And this stays for a long time, as St. Helens stays in the atmosphere for 10 years. Not really dangerous as a cloud, as a concentrated cloud, but there was a ring of dust, volcanic ash around the globe, and latitude of between 30 and 40 because of this St. Helens. So it stays in the air, and also, but it's very romantic, by the way, because you see very nice red sunrises and sunsets. You have this pollution in the air. But basically, this way. So of course, what I'm telling you now is a speculation. It's a speculation, but it's speculation based on facts and experience. And I can say I've been to this situation. I know what happens, and this is what happened to them. But they were killed before they moved on. And now, if you want to know the result, why they do not find the airplane, and I'll tell you very briefly. When a pilot is descending, what he's doing is selecting the target altitude and target speed. And now just what happens if the airplane descends and the pilot dies, and there is no one to change it anymore. The airplane gets to the altitude, levels off, and open the power and start running the engine. Now, if there was volcanic ash that stopped the engine or not, we don't know. So this is kind of a problem to this explanation. But it could be that it just had the poisonous gas and not really a thick ash. Anyway, after getting to the level and opening power, and there is no more pilots, the airplane will continue the last heading, which is the last magnetic or whatever was selected, and continue. Now it will be drifted by wind and move, but it will keep on the... Now, if there is no altitude hold, it will climb where there's a way, it will go down. If there is altitude hold, it will stay same altitude. It may be below the radar. And at a certain time, there is no more fuel. When there is no more fuel, they have one engine. First, always one of them will be first. And the autopilot corrects. And then a few minutes later, the other one. And then there is no engines, no generators again. But this is a sophisticated, 777 is a sophisticated aircraft. It has a chute with a generator, emergency generator, which comes off automatically. And as it is a fly-by-wire, two people cockpit, there are more and more sophistication and automation. When this generator is coming out, electricity is picking up, everything coming back to normal, autopilot connects, and the airplane continues to fly. Okay? Nice, for 7 hours. How do you know it flew for 7 hours? Because the Rolls-Royce engines on this aircraft every hour send a package of information to a computer in Rolls-Royce. Rolls-Royce wants to know what's going on with the engines all over the world. They don't have a GPS on them. So every hour, just sending a package. Now they found, 2 days later, somebody say, oh, we're getting this information, but nobody's looking at it because the airline is not paying us to give them the information. So I'm getting back to the point that the airline is not buying anti-volcanic ash cooling system, which is available, is not buying the information about volcanic ash, which is available, is not buying the data from the engines, which is available. Okay, so this is what I'm saying about saving money. This is saving money because we don't know. They have all the information, but nobody's looking into it and nobody's collecting it. Okay, so when now we're getting to the point that the aircraft, no engines, and continue to fly over the Atlantic and start descending, which is normal. Every airplane is designed. When you lose the power, the nose is going down and you maintain the speed. Okay, this is the basic design of aircrafts. This is done because we don't want a pilot that losing a power on an engine to stall. So automatically, when you lose the power on the engine, the nose goes down. This is how they build the airplanes. So the airplane was going down towards the sea. Now, when it's approaching the sea, the water, there is a system, a ground proximity system, which warns the pilot that you're too close to the ground. And if the pilot is not doing anything, the aircraft will flare and land when it gets to the ground. And now there was water probe. I don't know if it was wavy or not, but the airplane landed intact on the water. And now, a few minutes later, the air is coming out from the tanks, from the fuel tanks, and the airplane is sinking down in one unit. No parts to float, nothing, no oil, nothing is coming out. The airplane is sinking to the bottom as in one piece. So this is why they don't find him, and they don't even know where to look for him. But again,
as a theory, the plane should be intact.
What?
Somewhere. If that theory holds,
yeah,
the plane will be intact.
Yes, somewhere 6,000 meters below sea level. Okay, nobody will get over there.
But at least you can send a sound.
Yeah, but okay, they're working on it. Maybe they'll find it one day. Okay, I'm not sure, and maybe my theory is incorrect completely. But the point is, I'm talking not about the disappearance of the airplane. I'm talking about the airlines which are causing it by negligence. And now this is one of the problems. But now just imagine that you're flying the low cost like the German wings, and you have a first officer which is
unstable.
No, not unstable. 150 hours, flying hours. You know why? Because to get to 1,000 hours, it needs $500,000. Can you imagine? $500. It costs 1 hour on a twin engine instrument rating airplane. So if you want to train on instrument and twin engine, you need $500,000 to become a pilot. And then how would you pay back the money? So there is a shortage of 100,000 pilots all over the world now because the system doesn't supply pilots. Nobody wants to be a pilot, except crazy people like this one who all his life wanted to be a pilot, and now he's a pilot. 500 hours, he's in charge. The captain is going out to the toilet, and I wrote, on Facebook, I wrote a directive. Whenever the captain wants to go to the bathroom, we need to have to handcuff his hand to the first officer and take him with him. Okay, so this is again, I'm coming back to the airline and not to the pilot itself. The pilot itself is crazy. The pilot itself is now, but the fact that he's not trained, the fact that he never been to a simulator to simulate conditions like this is the failure of the company. Air France. 3 years ago, a flight from Brazil to Paris disappeared, right?
Uh-huh.
Now, also landed intact. This one is an interesting story. This one also, it was a first officer, inexperienced first officer, and now they did not take enough reserves, fuel reserves, and this is an important point. Airline, to save money, take less reserves. In 10 hours flight, you burn half of the extra fuel that you took, just to carry it. So if you want at the end of 10 hours flight, you want to have 1 ton of fuel extra, you will have to take 1.5 in order to burn the half ton. Now, this is wasting fuel. It's heavier for the takeoff. So the airlines try to predict the weather on the other side, try to see what will be necessary. If you need a diversion, you need to a different airfield, and they save the money on the diversion. Now, in this Air France, it was a policy to take the money, to take the fuel necessary for the flight. Now, the first officer was sitting over there, and in front of him was a big cloud. Front. The captain is sleeping. He decided, shall I wake him up? Well, you will say that I'm an idiot. Like, shall I divert? Now I need to talk Gander or whoever is controlling Santa Maria, whoever controlling the airways, to ask permission to divert to the side. I said, no. And I don't have, I'll do it, I'll lose time, and we don't have fuel. So I'll keep on going. So he kept on going into the cloud. The very first thing that iced up is the pitot head, which is the selecting, the sending signals to the air data computer. air data computer on those jets is a very important piece of equipment. It gives the altitude, it gives the airspeed, it gives many features that the airplane needs, but this is airspeed, but the source of the information is the two pipes. One is static, one is dynamics. One in front and one from the side. If this one iced up, automatically you're not getting what you need. And if you're not getting what you need, the airspeed is going up, so the first officer sees the airspeed is going up, so he starts reducing the power. Or trying to get this, but it's still going up. And what happens at the end? The airplane went down into the sea in full control of the first officer, which didn't know what altitude he was and what speed he was getting into. And the reason is lack of training and policy to save fuel. Okay, again, I'm going to the background of the system and not to the pilots. Although they are not clear of any responsibility, because two pilots, first of all, must be all the time in the cockpit. There is no way that one will go to rest and leave the other one flying. There is no such a thing. It happens only because they're tired. And they're tired because there are only two. And only two because this is the policy. And so that's it. And then they don't want to put cameras in the cockpit, okay? So nobody will know what they're doing. Okay, so.
How is it different from an hour?
No, we'll get to it. So now, if we'll have time.
Always fly alarm.
So now we see that Air France, Swissair, Korean, the Malaysian, Malaysian. I'll get to the Malaysian one also. Again, training, simulator training. Sorry, Singapore, not Malaysian. Singapore. Singapore airline. About several weeks ago, took out, and they had engine fire. So engine fire, one pilot flying, it was probably the captain, because it was right after takeoff. He was flying, and say, okay, now fire warning is a huge light and a very powerful bell that rings, and the light gives you the warning. And immediately, the procedure calls to pull up the fire switch and push in the fire bottle to extinguish the fire. Okay? And now, okay, after dying, this is the recall item. It's done automatically. And because you see the light, you pull it, the extinguisher button is next to it, and that's it. Now, you ask the computer to give you the fire checklist, because it's a computer now. It's not a paper. It's not written anymore. You don't see the checklist, you ask for it. So you are out of the navigation now, and you have to call the tower to tell the tower that you're in an emergency, and your position, and now you have to do the checklist. And one pilot is flying, the other one is under tremendous stress, okay? And so he takes the checklist, and the checklist says, okay, shut down engine number, whatever, on fire. And he looks at this one, he looks at this one, takes the engine and shut it down. Now, when you pull the fire switch, you shut the fuel at the source. When you shut the engine in the cockpit, it shuts immediately. So now he wrongly shut the other engine. So you have now engine on fire with a few seconds of power, and the other one is dead. Immediately the airplane turned down into the river. That's it. Why? Who is responsible for that one? A mistake. Pilot's mistake, right? But pilot's mistake, we know that pilots are making mistakes. So confirm that you're doing the right thing. Teach them in a simulator. In our airline, you asked about our airline, we teach on every flight wrongly shutting down the engine. On every simulator flight. And when it happens, it's acknowledged immediately, and they restart the engine. It takes seconds to restart the engine, and you save the airplane. But if you don't do it, there is Austrian one who land on the highway for the same reason, and this is Malaysia, Singapore, and I know about hundreds of mistakes like this in the simulator, and I know of many cases, real one, that did not end in fatalities. So This is training. This is simulator training. Now, about the Air France, back to the Air France with the flying without the airspeed indicator. This is also, if you ask what we do in our airline, we train the pilot for that. We give them, okay, you have no airspeed indicator and no altitude indicator. What do you do? Okay, you know your weight, because it's written all the time with the weight of the airplane. You open the power according to the weight and select an attitude of 3 degrees nose up, and that's it. Now, you're not losing altitude, you're not climbing, maybe a little, and the power will maintain the airplane until you find out how to solve the problem. But we do it on every simulator flight. And we have, according to the regulation, you need 4 hours a year on a simulator. We are doing 20. And sometimes Hong Kong was the old runway in the middle of in between the buildings over there, we were trained of Hong Kong before each flight. The crew was trained on a simulator before a flight to Hong Kong, just to make sure that the landing will be okay. So when, I'm coming back again to this one, to reduction or saving money. So they say saving money is a responsibility of the system and not the pilots. Saving money is a responsibility of the manufacturer of the aircraft. He wants to sell an airplane which is cheap to operate, and so on and so forth. Okay. I'm sorry. Okay, so. Huh?